Hey, Algebra 1, we're going to continue working in Chapter 9 here. We're going to do something that should be very, very, very familiar to you. We're going to start by factoring quadratics. We're going to do this by grouping, right? Building a bridge method. So first thing I'm going to do is 3 times 25. Well, that's 75. I can make it negative because remember the signs do have to be different. But I need the factors of 75 that subtract to give me 10. All right. So, sometimes kids like, I don't really know about that. I don't know what's going to happen. I don't know. Okay. So remember, it's 3 and 25. That's one. 1 and 75. That's another. It's 3/4. And they're like, I don't really know. But keep in mind, 25 is made up of 5 and 5, right? So what I can do is I can go with 5, right? Because it's definitely divisible in 15. But hey, there it is, 5 and 15. Okay, 5 and 15 have a difference of 10, and I want to make sure that I get positive 10. So I'm going to make the 15 positive because this would give me positive 10 in the end, and that's what we really, really want. So these two terms here, they're going to get dropped right in the middle of this guy here. I'm going to make them x's. 3x squared minus 5x plus 15x minus 25. Ooh, I was thinking 20 and root 20, but it's 25. I got to listen to myself here. All right, factor by grouping. 3x squared and 5x both have an x. And you're like, really? We're going to do this again? And I said, yes, we're going to do this again. All right, so I need 3x minus 5. No sign changer here. 15 divided by 3 is 5. 25 divided by 5 is 5. So I know that's going to be the next part. So x plus 5 and 3x minus 5. Okay, so that part is the review. Here is the new thing, right? Because we're moving on. We're going to use what's called the zero product property. And that means that if I set this whole thing equal to 0, that means each of these or one of these has to be 0. Okay, so what we'll do is factor like we always have. And then we're going to finish by solving these. So I might say minus 5 minus 5. X equals negative 5. So that's one answer. Here I'm going to add the 5. So I get 3x equals 5 and divide by 3. And my second answer is 5 over 3. Okay, so we're going to do everything we have done, but then we're going to solve these little linear equations in the end. So we're going to just walk you through some of these just to review all of it. Okay, 7 times 6, that's 42. You can say that it's negative 42 to remember that you want the factors that are one apart. Well, guess what? That's 7 and 6. I want to get negative 1, so I'm going to make it negative 7 plus 6 because that would give me exactly what I want. 7x squared minus 7x plus 6x minus 6. Dropping these two terms right in the middle. GCF 7x, so I get x minus 1. I need to get x minus 1 again, so that means my GCF must be positive 6 because I don't want to change the sign. So 7x plus 6, so here's the difference. We're going to write equals 0 and x minus 1 equals 0. And that's just to be efficient, right? We could still write it as the two factors the way we did in the last chapter, but eventually we want to get to this point. So minus 6 minus 6, so 7x equals negative 6 divided by 7. All right, so a little cramp for space there, but negative 7, 6. And the other one, we're going to add the 1, so x equals 1 as well. I like to circle those because I'm old and I just want to find out where they are. All right, so I just handpicked a couple of these, no particular reason. So 3 times 10, that's 30. It's going to be negative. So what factors of 30 are 1 apart? Well, that's 5 and 6. I hope you recall those. And if I want to get negative 1, that means the 6 has to be a negative and the 5 is positive. So here we go. 3x squared plus 5x minus 6x minus 10. All right, let's factor by grouping now. So 3x squared and 5x, they both have an x. So I want 3x plus 5. I need to get 3x plus 5. All right, so I know I have a sign changer, negative, and 6 divided by 3 is 2. 10 divided by 5 is 2, so there we go. X minus 2 equals 0. 3x plus 5 equals 0. So those are the two little equations that I'm doing all this work for that I want to solve. So we're going to add 2. X equals 2. So if you remember how to factor, then you're going to be like, man, this is awesome. If you had trouble factoring, you're like, man, this is awesome. I get some extra time to really work this thing out. Yeah. All right, so factor by grouping, we're going to continue with that. Let's see. I was going to say, I thought I had at least one more on the first page. Here it is. So we'll pick and choose. By all means, you can go and do any of these that you want once you know what we're doing here. So 2 times 12, 2 times 12, that's going to be, let's get that out of the way. That's 24. What factors of 24 add up to 11? Well, 1 and 24, that doesn't. 2 and 12, that does not add up to 11. 3 and 8, that'll give me 11. All right, they add up, and I want both of these to be negatives, right? So I tried to pick and choose some that had some sign things to talk about. All right, here we go. We got -3 and -8. Plug those in the middle. So 2x squared and 3x, they both have an x. So we're going to get 2x minus 3. I need to get 2x minus 3 again. So I do have to change the sign. So I'm going to use negative. 8 divided by 2 is 4. 12 divided by 3 is 4. So that works. So x minus 4 equals 0. 2x minus 3 equals 0. Because we want to use that zero product property. Add 4. So x turns out to be 4. We're going to add 3. This one has 2 steps. Now, so 3 over 2 or 1.5, whichever way you want to count that. Right, so we'll keep on working on a few of these. Notice they don't have equals 0, so we're just going to put that on there. We're just going to put that on there. Now, these numbers are a little bit on the larger side. So one thing I want to notice is 3 have 5 and 7. That adds up to 12. So there's a chance that's divisible by 3. And 27, I know 27 is divisible by 3. So let's check it out here. So can we do 57 divided by 3? You betcha, that's going to be 19. So let's do this. Let's take out the 3. So I got, again, I'm going to make these into x's. So x minus 19x plus, we get 270 divided by 3. Well, that's going to be 90. Wow, that problem got a whole lot easier, didn't it? How about that? So here's the thing is, when we were factoring, we'd have to keep this guy around. But what we're going to do now is I'm going to actually divide it by 3 on both sides. So this is all that I really have is this x squared minus 19x plus 90 equals 0. And what factors of 90 add up to 19? Well, that's 10 and 9. Okay, so I'm going to go straight to my answer. I don't have to factor by grouping because I had 1x squared. So I have minus 10 and minus 9 equals 0 and equals 0. I can squeeze those in. So I'd have to add the 10 and add the 9. So 10 and 9 become our solution. So this one here had a GCF. I don't want you to forget about some of those basics if the problem has a lot of stuff going on. And also, remember we had 1 in front here. It's 1 times 20. Makes that a whole lot easier. So what factors of 20 add up to 9? 1 and 20, 2 and 10, 3, 4 and 5. 4 and 5 it is. So it's going to be b minus 4 and b minus 5. I want to make sure we hit the factor by grouping before we reviewed these easier ones. Okay, it goes so quick I forget to write my equals 0, right? So b equals add the 4 to get 4, add the 5 to get 5, 4 and 5. All right, now I picked out just a few more. Remember, this is our difference of squares. So what happens here is now that we did the square root method, we could actually say that we're going to add the 49, take the square root, but I want to review the factoring as well. Remember, they're both perfect squares and we're subtracting, so it'd be p minus, not 4. What's the square root of 49? That's 7, and p plus 7. All right, now let's squeeze in equals 0 and equals 0, so p equals plus or minus 7, so I don't have to write both of them each and every time. All right, what about the next one? It has all 3 terms. Let's tack on the equals 0 because we're after solutions today. So factors of 25, 1 and 25, so 25, 1 and 25, 5 and 5. Which ones add up to 10? Well, that's 5 and 5. They both have to be negative, so I need x minus 5 and x minus 5. All right, well, when I have the same thing twice, remember what we do is we say that's one of them, and we're going to say squared. Squared, x minus 5 squared. Okay, here we go. We get a squared minus 6a plus 9. So we're looking at factors of 9 that add up to 6. Well, it's 1 and 9 or 3 and 3. Oh, here it is, 3 and 3. All right, so this is another one of these doubles, right? So it's x minus 3, x minus 3. What did I write that for? Remember, it's supposed to be squared. Squared, that's the way we want to see that answer. Okay, and what do we got over here? This is another one that's 64. You know the square root of 64? M plus 8. And m minus 8. Let's set it equal to 0. So m equals negative 8 and positive 8. Again, you could write it as plus or minus. So we're going to view all the factoring. That's what we got going on here. But now instead of telling me m plus 8 and m minus 8, the only difference is we want to actually give that final answer by solving those little linear equations in the end. That's it. Chapter 9 is going to be fantastic.